Scene script. Why does a hummingbird hover but a drone can't? Welcome to the fascinating world of aero and robotic dynamics. Imagine a hummingbird in flight. It flaps its wings up to 80 times per second, creating lift on both the upstroke and the downstroke. The wings move in a figure-8 pattern, allowing the bird to hover, dart forward, shoot up into the sky, or dive down to the ground. This is aerodynamics in action. Now consider a drone. It has 4 rotors that spin at a high speed, creating lift. But unlike the hummingbird, a drone can't flap its rotors. It can't create lift on the upstroke and downstroke. It can't move its rotors in a figure-8 pattern, so it can't hover like a hummingbird. This is where robotic dynamics come into play. Aero and robotic dynamics are 2 sides of the same coin. They're both about understanding and manipulating the forces of nature to achieve flight, but they approach this goal from different angles. Aerodynamics focuses on the behavior of air and other gases in motion. Robotic dynamics, on the other hand, focuses on the design and control of robots to interact with the physical world. Aerodynamics uses principles from fluid dynamics, a branch of physics that studies the behavior of fluids in motion. One key principle is Bernoulli's principle, which explains how the speed of a fluid relates to its pressure. When a fluid speeds up, its pressure drops. This principle helps explain why an airplane wing, or airfoil, generates lift. The air moving over the top of the wing moves faster than the air moving underneath, creating a pressure difference that lifts the plane into the sky. Robotic dynamics, meanwhile, uses principles from mechanics, a branch of physics that studies the motion of objects and the forces that cause this motion. One key principle is Newton's second law of motion, which states that an object's acceleration is directly proportional to the net force acting on it, and inversely proportional to its mass. This principle helps explain how a robot can move and manipulate objects. The hummingbird and the drone are both masterpieces of aero and robotic dynamics. The hummingbird, through millions of years of evolution, has developed a flight mechanism that's perfectly adapted to its environment and lifestyle. The drone, through decades of research and development, has been engineered to perform tasks that were once thought impossible for machines. To summarize, aero and robotic dynamics are about understanding and manipulating the forces of nature to achieve flight. Aerodynamics focuses on the behavior of air and other gases in motion, and uses principles from fluid dynamics. Robotic dynamics focuses on the design and control of robots to interact with the physical world and uses principles from mechanics. The hummingbird and the drone, though different in many ways, both showcase the power and beauty of aero and robotic dynamics. They show us that with a deep understanding of nature's principles and a bit of creativity, we can achieve the seemingly impossible. And who knows, maybe one day, we'll create a drone that can hover like a hummingbird. But for now, we can marvel at the wonders of aero and robotic dynamics and dream of the possibilities they hold for the future.